Good evening, my dear student. I am Rakesh Chaubey from Sunbeam Sun City. Jai Hind, you all, my dear. I got one questions from the email from the student side during the miscellaneous problem and the limitations of dimensions. I will discuss with these topics. The question is from the student is in the given expression there is an expression P is equal to, P is either pressure, power, that doesn't make a sense for us. P is take P, it's an alphabet, is equal to E L square m power minus 5 g power minus 2 is dimensionless quantity. We have to show this P, whatever it is, say it is one alphabet, it is dimensionless. When it will be dimensionless? When the right hand things which are given as E, L square, m power minus 5, g power minus 2, when they don't have dimension, when their dimensions after calculation is getting L as 0, m as 0 and t as 0, then I will say this quantity is dimensionless. Simple. Because in every dimensions there is an involvement of length, mass, time. So when I say this will be dimensionless, when the right hand things which is given to me, that is E, L square, m power minus 5, g power minus 2, if all these have a dimension as L power 0 and m power 0 and t power 0 after solving all these four quantities, then I can say P is dimensionless. Now what is this four quantity? E is energy, L is angular momentum, right? This is given in the question. M is mass and G is gravitational constant. So what is your aim? Right now I hope you all understood. We have done so many questions on dimensions. That's why we need to calculate every dimensions first according to their formulas, and then we have to substitute. And after substitutions, if we get L as 0, M as 0 and T as 0 for right hand side, then I can say the left hand side, the things which is given as P, it is dimensionless. So let's start here to show P is equal to E L power 2 m power minus 5 and g power minus 2 is dimensionless. That is, dimension for L, M and T is 0. That is L0, M0, T0. Then only I can say dimensionless. Okay. Now let's start from this. Now my dear, the very first I should go for a rough work. So here I am taking rough work. Let's start. The first quantity is E. E is energy. Everybody know the first quantity is E. E is energy. Energy as work, and the dimension is nothing but L2 M1 T minus 2. I hope everybody now till now the dimension for energy or work is learned. Now next is angular momentum L. Now my dear, here I will give formula angular momentum, right? Now angular momentum has a formula nothing but linear momentum multiplied by perpendicular distance. Now you all know from class 10th, my dear, I solved this also. From class 10th, you know linear momentum is mass into velocity into perpendicular distance. Nothing doing with perpendicular distance can be taken as L, right? So here the dimension for this will be m power 1. Velocity dimension is L power 1 t power minus 1, and this is L. So the dimension of angular momentum, my dear, is nothing but L power, here it is 1, so L power 2 m power 1 t power minus 1. This is the dimension of angular momentum. Angular momentum. Please don't get confused with this L and this L. This is length and this L is a representation for angular momentum. Okay, given in the question. It can be some other alphabet also. It can be I also, because I got the question as I here. But my dear, the standard abbreviations for angular momentum is capital L or small l. Okay. Now let's go for the next one is the mass. Mass everybody know m. Mass dimension everybody know L power 0, m power 1, t power 0, no else. Now next is gravitational constant G. The dimensions of gravitational constant G, my dear, you can see here, you all know that the formula is Fr square upon m square, the dimensions for this, the formula for this. Now this will be nothing but L1 m1 t power minus 2 force, and L r square is L power 2, and this is m square. Now be very fast for calculating all this dimension. This is the formula, this is the dimension. Okay, so gravitational constant as a dimension of, this is L power 1 and L power 2 become L power 3, m power 1 and m power 2 become m power minus 1 and t power minus 2. So these are the dimensions for energy, for angular momentum, for mass, and for gravitational constant. I have observed this. Now I will substitute what is given over here. So let us substitute this. So now let us substitute here all the dimensions. So here I am writing, this is dimension of T is equal to, this is E. Here E is given as L2 m1 t power minus 2. Next is, here it is L is angular momentum. I have written the dimension of angular momentum, you can see here. So this is nothing but L2 m1 t power minus 1. This is not L, let me tell you, this is not the length, this is angular momentum. So please take care of that. Okay, so L2 m1 t power minus 1 whole power 2. Okay. Now next is, or I can say, if I wish to take an alphabet, say here it is I. Say I have taken I, and I is representing angular momentum. Let it be. So I am changing the alphabet. So now let I be the angular momentum, because I got the question as I from the student. But I thought that let me give you the standard abbreviation, because generally in higher class when you'll go for a right abbreviation for angular momentum, it is L. But now if I put L, you should not get confused with the length ka L and angular momentum L. So let me change the alphabet. So let the I is taken as the angular momentum, because now you are doing for the first time, so you should not be any confusion. So this is I power 2, here I power 2 in the question. So but I has an angular momentum and dimension is this is whole power 2. Next is m power minus 5, m power minus 5, that is nothing but mass. So this is mass power 1. I have not written L power 0 and T power 0, no need. Here I will put minus 5, or if you wish I will write that also. L0 m1 T power 0 whole power minus 5. And here it is a gravitational constant. Gravitational constant is L power 3 m power minus 1 and t power minus 2 whole power minus 2 whole power minus 2. I hope it is clear. So I will repeat the dimension of energy, the dimension of angular momentum, the dimension of mass, and the dimension of gravitational constant. My dear, I will change the abbreviations for angular momentum. As I got the question as I have taken I as, because I have not taken L, otherwise you will confuse with this L and the length ka L. Please make a note of that. So now let us go for the next step. This is the dimension of P is equal to, let us, I will write this as L2 m1 t power minus 2. But here, my dear, this is L2 and here it is 2. So this 2 and this 2 become L power 4. This is m power 1 and this is 2. Will be 1 into 2 will be 2. And this is t power minus 1 into 2 will be minus 2. Now next is here L power 0, m power 1 into minus 5. 1 into minus 5 will minus 5. T power 0 into minus 5 0. And here it will be L power 3 into minus 2 will be minus 6. M power minus 1 into minus 2. Minus and minus become plus, 1 into 2 will be 2. And t power minus 2 into minus 2, my dear. Minus minus again plus, and 2 2s are 4. 2 2s are 4. Now there it will be P is equal to, this is, my dear, now let's start. This is L power 2 and L power 2. So this is L power 2 plus 4 plus 0 minus 6. 2 plus 4 plus 0, and here it is minus 6. M power, my dear, let us go for M. Here it is 1 plus 2 minus 5 plus 2. Minus 5 plus 2 I have written. And last is T. T power minus 2. Here it is minus 2. Next one is also plus 0 and plus 4. So now what is the dimension I am getting, my dear? This is P is equal to, once again, this is L power, this is 2 plus 4 plus 0 and minus 6. M power, this is 1 plus 2 minus 5 plus 2, right? There is plus 2. And T power minus 2, right? Here it is minus 2. So minus 2 plus 0 plus 4. So I hope it is clear. So now here it will be L power 6 minus 6, M power, you can see 3, 2 plus 1 3, and minus 5 plus 2 will be minus 3, and this is T power minus 4 plus 4, minus 4 plus 4. So now here this is P is equal to L power 0, M power 0 and T power 0. Thus, that is, it become, my dear, dimensionless. Therefore, P is equal to, the formula is E L square, I square, I mean to say, E I square M power minus 5 G power minus 2 is dimensionless, hence proof. So the formula which is given is dimensionless, I proved it. So this is the way, my dear. So please check it out. This is a simple question. It's not a difficult. Only here you need to know each and every dimension. You should know dimension of energy. You should know dimension of angular momentum, that is linear momentum into perpendicular distance. Linear momentum is m into v. Everybody know from class 8th 9th that it is nothing but a momentum. Now it is called linear momentum, mass into velocity, multiply by perpendicular distance, that is distance is taken as L. So this is m ka dimension, v ka dimension and L ka dimension will give me entire, if I have calculated L2 m1 t minus 1, give me a dimension of angular momentum. And my dear, I have changed the abbreviation. Earlier I have taken capital L, but in between I have changed the abbreviation because this L of angular momentum should not get confused with the L of the length. But my dear, I have taken the standard abbreviations because in higher classes or in the class of the 11th itself, when you will study the angular momentum quantity, the denotation will be, actual denotation is L. So I hope it is clear, and mass dimension is known to you, and this is gravitational constant. Formula Fr square by m square will give me the dimension L power 3 m power minus 1 t power minus 2. As soon as I will substitute these dimensions for quantity, energy, for angular momentum, for mass and for gravitational constant according to the power which is given in the question. Here energy has a power of 1, so I have put 1. My angular momentum has power 2, so I put the dimension of angular momentum, I put the power 2. Mass ka dimension I put and put power as minus 5. Gravitational dimension, constant dimension I put here and the power is given as minus 2, I put minus 2. And then I use algebra to multiply and get the things. So I hope you all understood. Now let's go to the next question. Let's now, my dear, go to the next question. As I said, it is a miscellaneous. So one question is from the student side. Now look at the next question. Student also complaining about this kind of a question that they are not understanding. It's a simple one. If the unit of force is if the unit of force is 1 kilonewton and unit of length is 1 kilometer, right? So here I will write force is 1 kilometer. So I'll write what is given. So here is the solution. Force F is given as, my dear, 1 kilonewton. Everybody know this will be 10 power 3 Newton because kilo word is given. Next is, my dear, it is given length. Length is 1 kilometer. Again kilo is given, so it is 10 power 3 meter. And next is time. Time is given as 100 seconds. This is all given, and here I am writing given. This is all given, my dear. Now what will be the unit of mass if these things are given? Question is very clear to you. If this thing, if the force is given 10 power 3 Newton, length is given 10 power 3 meter and time given 100 seconds, that time what will be mass? That's a question. So here first you all know that, sir, where the mass is involved. So now among these three things which is given to you, I hope force is that derived quantity. Force, everybody please, I am going to the back, but still please take care, because length and time is fundamental. Even the question which is asked for mass is also a fundamental. So force is the derived quantity here which derived from length, mass and time. So of course in the formula of force there is a mass involved, because force depend upon mass. Am I clear? So everybody aware about one formula, because here out of this 1, 2, 3, 4 quantity, force, length, time, mass. So length, time, mass is fundamental. Only force is derived, and this force is derived from length, mass and time, and there we will get mass. So what is very important, we should know first, can we write force as everybody know about it? What is the dimension of force? The dimension of force is nothing but here the dimension of force is required. So here it is L1, M1, T minus 2. Everybody please take care, this is the dimension of the force. No issues about it, because you should know that force involved mass. So now my dear, what is mass? So mass is, can I write down this as L power 1, yes, M power 1, yes, and T power minus 2. Okay. Now here I keep M power 1 here only because that is mass. Am I clear? Whereas here I will get dimension of force divided by, this will be here L power 1 and here it will be T power minus 2. I brought L power minus 1 and T power minus 2 at the denominator of F, and here it is M. Simple algebra. Okay, this and this I calculate. Okay, and I got M. So now I got the M. So here my dear, F is given as 1000 Newton divided by my dear L power 1, here you can see F power 1, L power 1 and here also T power 1. So now L power 1 is given as 1000 meter, you can see my dear, and here this is T power minus 2. See, please take care, T power minus 2. T power minus 2. So here T power 1 is given. So here it is 100 power, that is 100 second, and here it is power minus 2, because minus 2 is in the dimension. Simple. And this is your mass. So now what will be the answer for it, bacho? This is 1000 and 1000 is cancelled. You can see, you all can see 1000 and this 1000 become what? That is nothing but my dear, this is cancelled, you can see. So now Newton per meter, that doesn't make a sense. And here it is 1000 second power minus 2. Now 100 second power minus 2. So can I write down this as 1, because this is 1. This become 1. Right? And this is, I'll write unit also, Newton. Here I am getting meter, and here I am getting second power minus 2. So this can be written as Newton, and this M will go up, meter power minus 1, and this S will also go up, become S power 2. Am I clear? And here it is 100 ka power minus 2, my dear. When it will go up, or I will write here, this is 100 power minus 2, which can be written as, my dear, and this is equal to mass. I hope it is clear. What I did? My dear, here it is 1, here it is 1, 1000 cancel. Unit will be Newton, yes, Newton. Meter is here, I have put meter power minus 1, and this S power minus 2 is here. You can see. So S power minus 2 taken up and it become S power 2, and here it is 100, that is 100 I kept as it is, power minus 2 is equal to M. So now what will be the answer here? So here it will be, therefore M is equal to, my dear, this is M is equal to, this is 1 upon 100 power plus 2, because this is 1 upon 100 power minus 2, so it will be 100 power plus 2 N Newton meter minus 1 S2. And now my dear, this is nothing but 10 power 100, na? So this is 10 power 4, because this is 10 power 2 as 100 whole power 2, Newton meter power minus 1 second power 2, and this is 10 power 4, 2 2s are 4, Newton meter inverse second power 2 is your mass. Now my dear, you must be wondering, sir, the mass ka unit is kilogram, but while calculating, my dear, I am getting Newton meter power minus 1 second power 2. The reason is that you all can convert. Here I am giving you hint. See, Newton meter power minus 1 second power 2 can be written as, what is Newton? Newton is force. Can be written as kilogram. What is the another unit for Newton? I have told you the Newton ka another unit, kilogram meter per second square. Right? into, this is meter power minus 1 into second square. Now second square cancel. Meter and meter power minus 1 is also cancel, my dear, because this is 1. So this is m power 1 and m power minus 1. So this is cancel and the unit become kilogram. So I hope it is clear that m is equal to 10 power 4 and this entire thing is called kilogram. मैंने कन्वर्ट करके दिखाया. I have converted it. You can see. मेरे से जितना हो सकता है I am doing in my video. You can see Newton meter power minus 1 second square can be converted as Newton can be written as mass into acceleration. Newton का formula mass into acceleration. Mass का unit is kilogram. Acceleration का meter per second square. Okay, तो Newton हो गया. Into meter power minus 1. Into second square cancel. Meter power minus 1 and this meter power 1 become cancel and what will be left out? Kilogram. So ultimately, sir, Newton meter power minus 1 second square is kilogram. So here you can see, my dear, and here I proved it because you must be thinking, sir, force is in Newton. I have written Newton. Here length is in meter. I have written meter. Here time is in second. I have written second. But then, my dear, what I did, 1000 and 1000 cancel. This is Newton, yes, this is meter, but this meter is in denominator, taken up minus 1, and this S, that is second power minus 2, this will go up, become second power 2. And here I kept it, only the number is 100, whole power 100, this is 100, I have written as it is, and here it is power minus 2, I have written minus 2. So when I converted this 100 power minus 2 will go up, 100 power minus 2 will go up, become 100 power 2, and the unit is Newton meter power minus 1 second square. This is 100 power 2 can be written as so, and so the answer will be 10 power. So I hope it is simple questions, so please take care of such questions, don't worry about this. These are a very simple question. There is nothing, I have substituted the value. T value is 100 second, I have taken 100 second. Power minus 2, I put minus 2. Then what I did, 1000 and 1000 is ultimately cancelled, and I have thought to give you a knowledge with the unit also. So I have written unit Newton, this is meter power minus 1, and this second power minus 2 will go up, become second power 2. And then here entire thing is 1 in numerator. So here I have written 1, but in denominator it is 100 power minus 2. Don't forget it is power minus 2. So when this will go up, it become 100 power 2. Newton meter inverse, Newton meter power minus 1, जिसको inverse भी बोलते हैं, second square. So this is 100 can be written as 10 power 2 का whole power 2. Newton meter inverse or meter power minus 1 second square 10 power 4. And then here I have shown how Newton meter power minus 1, Newton meter power minus 1 second square become kilogram. ये भी एक बहुत अच्छी चीज है. So देख लो, Newton को sir we can write mass into acceleration because Newton is a unit of force. And in my earlier 10 dimensions में I told you Newton can also be written as kilogram meter per second square, another name. So I have written Newton as kilogram meter per second square into, here it is given meter power minus 1 and here it is given second square. Second square cancel, meter power 1 and meter power minus 1 become meter power 0, that is 1, and the unit left out is kilogram. So ultimately this is nothing but kilogram. So that's all from my side in this video, my dear. And next I am uploading the second video on this topic.